Hi, everyone. Thanks for being here today. I'm Charmaine. We're going to talk about AI revolution, reality or myth. It's a project that I worked together with Dennis and Alexey on. We'll explore how AI is changing the world and what it can really do. We'll also cover the basics of AI, see where it's being used, and look at some of the latest breakthroughs. Plus, we'll talk about some of the challenges and what the future might hold. Let's get started. AI is about creating systems that can perform tasks typically needing human intelligence. AI has evolved significantly thanks to better algorithms, more powerful computers, and more data. Artificial intelligence was first used in 1956 at the Dartmouth Conference, and AI has had its periods of rapid progress called AI springs and slower periods called AI winters. Recently, AI has been booming again, with lots of new research and applications emerging. AI includes a bunch of cool techniques like machine learning, deep learning, natural language processing, NLP, computer vision, and robotics. Machine learning is all about creating algorithms that can learn from data. Deep learning, which is part of machine learning, uses neural networks with many layers to get better at recognizing patterns. NLP, or natural language processing, helps computers understand and produce human language, while computer vision lets them interpret and analyze visual stuff like images and videos. Robotics takes AI and puts it into physical systems, allowing things like robots to operate on their own. AI is used in a lot of different areas. In healthcare, it helps with diagnosing diseases, planning treatments, and finding new drugs. In finance, AI is behind trading, spotting frauds, and customer service chatbots. For transportation, AI powers self-driving cars and figures out best routes. In e-commerce, AI gives you personalized shopping recommendations and helps manage a supply chain. And in entertainment, AI suggests content that you might like and powers virtual assistants. LLMs, or large language models, are a big leap in AI, especially for understanding and using human language. Using deep learning, LLMs are great at tasks like writing text and translating languages. They started with simple techniques but got better with neural networks. The game changer was transformer architecture in 2017, leading to famous models like OpenAI's GPT series, Google's BERT, and Facebook's Roberta. These models can learn from huge amounts of text and are fine-tuned for specific jobs, making them perfect for virtual assistants and customer service chatbots. Training large language models takes a lot of data and computing power. First, they learn from huge collections of text using methods that don't need labeled data, like predicting the next word in a sentence. Then, they are fine-tuned for specific tasks with labeled data. Transfer learning helps these models apply what they've learned to different tasks and fields. Large language models are used in a bunch of different ways, like in virtual assistants, platforms that create content, tools that help complete code, and customer service chatbots. They're really good at understanding and processing human language, which makes them perfect for AI systems that need to interact with people naturally. They are the core technology behind conversational AI systems and are widely used for generating content, finding information, translating languages, and giving personalized recommendations. Machine learning lets computers learn from data to make smart decisions and automate tasks. It includes different types like supervised learning, unsupervised learning, and reinforcement learning. You can find machine learning in many areas such as healthcare, finance, transportation, and e-commerce, where it helps solve complex problems in various ways. AI research focuses on several key challenges and opportunities. These include making AI better at generalizing knowledge and applying it to different tasks, enforcing AI security and making it more robust against attacks, improving how we explain and understand AI's decisions, reducing bias and promoting fairness in AI systems, ensuring AI is used ethically and responsibly, enhancing collaboration between humans and AI, making AI more scalable and efficient, enabling AI to learn and adapt continuously. Addressing these challenges requires collaboration between universities, industries, governments, and the broader community. In short, AI has changed many fields by doing tasks that used to need human intelligence. AI has advanced a lot thanks to better algorithms, more computing power, and lots of data. Techniques like machine learning, deep learning, and large language models have revolutionized industries like healthcare, finance, transportation, e-commerce, and entertainment. But AI still faces challenges like being reliable, fair, understandable, and scalable. To overcome these, we need teamwork from everyone to ensure AI develops ethically and responsibly. As AI continues to grow, it can further transform our world and become a key part of our daily lives, driving new innovations. Our project includes a fun coding task that shows how AI can predict what you might type next. We're using a pre-trained large language model to guess the next word based on the letters you've already typed. As you type, the model analyzes the letters and suggests the next possible word in real time. Think of a tree, like a tree where each branch represents a letter in a word. When you follow the branches from the root to the leaf, you spell out a complete word. This makes it easy to find words that start with the same prefix. Each branch in the tree can split into multiple branches with each branch representing a different letter. This setup helps the tree handle and search through a lot of words quickly. Adding a new word to a tree is simple. Just follow the path for each letter in the word and add branches as needed. Removing a word is just as easy. You just remove the branches for each letter in the word. Trees are good at saving space compared to other data structures like hash tables because they don't need to store the whole word at each node. Instead, they only store individual letters. The time it takes to add or find a word in a tree depends on the length of the word. You just follow the branches for each letter. So if a word has n letters, it takes O(n) time to insert or search for it. Our implementation consists of two classes, a tree node class to represent the node structure and a tree class for the methods. The tree node class represents the node structure of a tree. If you think of each node as a part of a tree that represents a single letter. The children are like a dictionary or map that stores the next letters or nodes connected to the current letter. The frequency is an integer value that acts as both a Boolean marker for the end of a word and a counter for how many times the word occurs. The constructor creates an empty node ready to be filled with letters. Check if node is empty is a method to see if the node has any children or if it's just an empty node. The tree class. Insert adds a new word to the tree letter by letter. Search checks if a specific word exists in the tree. Starts with finds if there are any words in the tree that starts with a specific set of letters. Remove string deletes a word from the tree. Traverse from prefix starts from a given prefix and traverses the tree from there. Traverse walks through the entire tree. The generators yield and yield from are special methods that allow you to get each word from the tree one at a time, and this is used as an alternative to return. We start with a blank slate, an empty tree ready to store words. We insert words including duplicates. Adding words into the tree, even some of them are repeated, helps in testing how the tree handles duplicates. We test traversal to check if we can walk through the tree and see all the words stored inside. Next, we test search for an existing element. We look for a word we know is in the tree to see if the search function works. We also test search and remove a non-existing element. Try to find and delete a word that's not in the tree to make sure the tree handles it correctly. We also test remaining methods in the tree class, including traverse from, which starts from a certain point, which is a prefix, and traverses the tree from there to see what words that come up, and start with on a non-existent substring to see if there are any words that start with a set of letters that aren't in the tree. Start with existing substring checks if there are words that start with a set of letters that are definitely in the tree. These are the functions we use to train our model. Text from URL fetches text from a URL and stores it for later. The more text we feed our model, the more extensive its vocabulary becomes. Tokenizing the text cleans the text of special punctuation, characters, spaces, and digits. Fill tree adds the words from the list into the tree. Removing the rare words removes the least common words. And get top n finds the top n most common words that start with a given prefix. Some of the tests we performed were the top 10 most common words used in the text, the top words by prefix, and the user input for testing. Basically, the user inputs a number and a prefix to see which top words match the prefix. This is a list of resources that we use to complete our project. Thanks for listening.